Hello to everyone and welcome to today's virtual event, which is the beginning of a three-part webinar series for software-defined access with Catalyst Center. My name is Tanner Swift and I'll be your host for today's session. I'm excited to introduce some incredible speakers for you today, but before I hand the mic over to our presenters, we do have a few housekeeping items to cover about this presentation. Today's virtual event will be recorded and made available on demand after the live session. The playback will also be available on YouTube for rewatch as well. We'll provide you with some further details at the end of today's event. Also, we'd love to hear from you during today's presentation. During the session, if you have any questions for our presenters, you can submit them via the audience Q&A section on Slido, where we will answer your questions live or during the Q&A portion of today's event. You'll see some QR codes sprinkled throughout today's session where you can participate, so be on the lookout for those. Also, there's a word cloud poll available right now. Let us know where you're tuning in from today. So without further ado, I would like to welcome our first speaker for you today, who is excited to discuss how to protect your critical assets and data through Cisco SD Access. We'll kick things off by first sending it over to Kavita Badola. Kavita, right over to you.
Thank you, Tanner. Hello, everyone, and welcome to today's session, Getting Started with SD Access. My name is Kavita Badola, and I'm your speaker for today. I also have with me my colleague, Casey Hamilton, who is also a solution architect with Cisco CX Systems. And he's going to be my co-speaker today and also demonstrating a live demo for you all towards the end of the session. So we're going to start off with an overview of software-defined access. We'll talk about why we need software-defined access and what were the problems or what are the problems currently in our traditional networks and how we are going to move away from traditional networks to much more agile and automated networks, or what is really the need to move forward. After that, we are going to dig deep into SD Access fabric roles and terminology. And then we'll talk about how we can do network segmentation using SD Access on Catalyst Center, which will be followed by a quick segmentation demo on Catalyst Center that Casey would be doing for us. So before we begin talking about SD Access, let's quickly talk a little bit about why we need SD Access and what are some of the challenges or obstacles that most network engineers face when they are troubleshooting, or when they are troubleshooting and when they are managing the traditional networks. So the first one is that the traditional networks are very complex to manage. They have very limited automation support and often what we call box by box approach. The manual upkeep of automation scripts means errors and additional overheads for us. Secondly, slow issue resolution. So many times it is very difficult for our IT to troubleshoot any issue. I mean, if they cannot replicate the issue or see it in real time, and what results in that, network operators eventually spend more time collecting the data rather than analyzing the issue. So most network quality issues take hours to either resolve or prove that the network is not at fault. Then the third issue that we face with our traditional network is about segmentation. So traditional subnets rely on VLAN, IP addressing, ACLs, your firewall rules, and your VRFs for segmentations. But often we have separate policies for wired and wireless networks. With increase in our user segments and when we are expanding our scope, in our networks to IoT, etc., it's getting more and more complex and more difficult to manage and to really maintain and create that effective segmentation, which we really need in today's world. So Cisco SD Access is a solution that is built within Catalyst Center on intent-based networking principles. The solution provides us visibility-based, automated, end-to-end segmentation to separate user, device, and application traffic without really redesigning the underlying physical network. So Cisco SD Access automates user access policies, so organizations can ensure that the right policies are established for any user device or any application across your network. With this unified access policies across LAN and WLAN, a consistent user experience is created without really having to compromise on security. When we combine security and network operations, SD Access enhances this visibility by defining the access policies and automating our network configurations to implement these policies. Now, SD Access Fabric runs on normal networking devices, which are managed by Catalyst Center. While Catalyst Center will define the policies and it will deploy the configurations to all your network devices, it relies on Cisco ISE to enforce the policies across your network. So the main point of implementing software-defined access is ensuring that we have that communication established between Catalyst Center and ISE and the network devices as well. Now, let's see how this SD Access Fabric that we're talking about, how it can help us overcome the traditional network challenges or limitations or issues that we just talked in the last slide, such as the box-by-box automation or limited network visibility and non-scalable segmentation approach. So the first one that you see listed here is the automated network fabric. So it is automation. So since SD Access has, as I mentioned, complete automation via Cisco Catalyst Center UI, the automation is more scalable as compared to the box-by-box approach that we see in the traditional environments. So that results in consistent configuration, and it also reduces the chances of any manual errors. The next one is the identity-based policy enforcement. So unlike traditional networks, Cisco SD Access decouples the identity of the user from VLAN and from IP address. The policy enforcement happens based on the identity of the user itself, which means end users can roam freely and policy will follow the user. Endpoints can connect through wired or wireless media. They can have any IP address or they can roam around. It really does not matter because the policy will be based on the identity of the user. Then finally, Catalyst Center collects a lot of information from different sources. Then it analyzes and it correlates all that information and it provides us with some actionable insights against for the user and application experience based on the telemetry or information that it collects. Now, other thing is today, as we know that working on networks or when we are working on different networks, we have multiple technologies or multiple touch points, right? So these touch points are managed by, you can say, different teams. There could be a SecOps teams, there could be a NetOps teams, and within NetOps teams, we could have different wired and wireless and teams, and we can have collaboration, operations, and all of that. Now, let's say that everything is working in sync for us. We bring up one side, the configurations are validated, things are looking good, the network is working as we have expected. But there is a possibility, a very high possibility, that as the time evolves and as our teams evolves, the network also evolves. The things change. Some changes that are done along the way, maybe they were documented, but some there is a possibility that they were not. And now let's say that there is a time for any big merger or big acquisition, and your company decides to expand to multiple locations across the geographies. So what should be our best approach here? Do we start from scratch, or do we try to keep it consistent with that one site that we created? So that all the subsequent branches are really, in alignment with the technical and business goals. Now, to answer that, I want to begin with the first capability that often drives the organizations towards SD Access, and that is to use different workflows to deploy configurations. That you can see on the right side of the slide. There are different workflows that you can use on Catalyst Centers. And these workflows are defined by an intent. An intent could be, I want to define a VLAN, I want to create an SSID, I want to instantiate an IP pool, or I want to define a policy. So it basically comes down to what my end goal is going to be. And now each time this workflow is run from the Catalyst Center, it goes ahead and it deploys the same configuration consistently at each and every site that you decide to bring up. Now, intent-driven automation, again, now this intent or these workflows that we saw in the last slide, at the back end, what happens is that they translate into best practice configurations. These are written by subject matter experts, very thoroughly validated using Catalyst Center automation. It then goes on to configure one, or you can say even thousands of devices right from the UI itself, just using a few clicks. And that's the first thing, when we talk about the intent-driven automation, is that this is the first thing that we get with SDA Access. We get this consistent best practice automated configurations for different networks at a scale. Now, when it comes to securing these intent-based networks, these intent-based sites that we have created, SDA Access inherently complies with the zero trust for workplace architectures and its principles. And what are those principles? It's basically to trust no one, just no one from within my organization, no one from outside my organization. And its job is to continuously verify, continuously validate who is on my network. Now, this might sound straightforward, but it is not straightforward as just flipping a switch. Having a zero trust for workplace deployed across the organization is really a combination of multiple steps that we need to take to eventually get there. And this is a journey map. This is like a screen grab that I got from the Catalyst Center dashboard. This you'll see this journey map on the Catalyst Center, and this will tell you what are those steps that you need to take. What are those different levers that basically you need to turn on when you are beginning with your SDA Access Zero Trust journey. Primarily, it is visibility, it is trust and segmentation based on what is relevant for your organization at that point in time when you're starting with your SDA Access or Zero Trust journey. You could take those steps. So you can consider this as a tool on Catalyst Center that's kind of giving you insights as to how far ahead you are into the Zero Trust for workplace journey and what more is needed to be done to 100% eventually get there for your specific network. Now, talking about Zero Trust and network access and security, integration of Catalyst Center and ICE plays a very crucial role, as I mentioned earlier. What do we get as the result of the integration right off the bat? What we get is the end-to-end segmentation, end-to-end automation of configuration and segmentation policies. What I mean by that is we define all the policy constructs on the Catalyst Center. That intent is pushed onto the ICE. At the same time, we also configure all the devices with the relevant configuration, AAA, CTS, radius, TACACS, and all of that, so that as and when the users start coming onto the network, they are dynamically onboarded in ICE. So what we are doing is that we are taking that goodness of ICE, we take that automation from the Catalyst Center, and that once again makes implementation of your policies and segmentation and onboarding of your endpoints and all of that process really simple. And we will be discussing more on the segmentation later in the session as well. And Casey would be doing a live demo on that as well to show you how it really looks like on Catalyst Center. So the reason ICE is used basically to enforce the policy across the network rather than us utilizing more traditional methods like ACLs is, of course, to ensure a more consistent experience across all types of network devices. So rather than each device having unique access control lists crafted for each subnet and wired and wireless devices being managed independently of each other, all devices, regardless of how they are connected to the network, are subject to the same security policies that are enforced by Cisco ICE. So this really means that troubleshooting is much simpler and that roaming appears to be very seamless and very simple as well. Now let's look at some SD access fabric roles and terminologies. So let's begin by talking about what is a fabric. So SD access architecture is supported by fabric technology, which is implemented for the campus, enabling the use of virtual networks running on a physical network, which is your underlay network, creating alternative topologies to connect different devices. Fabric is really an overlay, and an overlay is a logical topology that is built over the underlying physical network. The overlay concept is not really new. It has been in practice for a very long time. Few well-known overlay networks are like CAPWAP in wireless, GRE, MPLS, IPsec, etc., which are well known to everyone. Now, why do we need these overlays? So overlays basically provide us an alternate forwarding attributes or additional parameters which can be used to provide additional services. With traditional or with physical underlay networks, these services cannot be used. For example, unless we have a CAPWAP tunnel or an overlay network, we cannot send wireless frames over wired or Ethernet network. Another example is IPsec, where we get additional attributes such as encryption and authentication. So what does this mean in SD access? In SD access, it means to create mobility, to create segmentation and visibility. SD access uses logic blocks called fabrics, which leverage virtual networks, overlays driven through programmability and automation. Network virtualization really becomes easy to deploy through SD access segmentation, and we get consistent policies for wired and wireless campus. Now, talking a little bit more about SD access fabric and the overlay underlay concept. If you look at this diagram, we have the endpoints, and these endpoints could be laptops, desktops, IP phones, printers, etc., which are physically connected to an edge device or different edge devices. And these edge devices are just your access switches where endpoints basically connects to. Edge devices are also where the overlay tunnel originates or where the overlay tunnel terminates. Underlay network is the actual physical network devices and your connectivity. So underlay network leverages the underlay control plane to learn the reachability information of edge devices, and based off of this learning, an end-to-end overlay tunnel is established between the loopbacks of these different edge devices. Once the overlay tunnel is established, it leverages control plane to exchange the reachability information of endpoints. Once we have endpoint reachability learned and established, we leverage the encapsulation to forward the traffic in data plane with additional attributes. So in Cisco SD access, single physical networks are abstracted and can host one or more logical overlay networks orchestrated through software. Now, let's talk about some of the building blocks, you can say, of SD access fabric. In SD access fabric, your control plane is based on LISP. In traditional networks, the IP address associated with an endpoint defines both its identity and location in the network. In these networks, the IP address is used for both network layer identification and as a network layer locator. This is commonly referred to as addressing following topology. While an endpoint's location in the network will change, who the device is and what it can access should not change. The locator ID separation protocol, or LISP as you call it, allows the separation of identity and location through a mapping relationship of these two namespaces. An EID, which is an endpoint's identity in relationship to its routing locator, or what you call RLOC. Then our data plane in SD access fabric is based on VXLAN. VXLAN is an encapsulation technique for data packets. When encapsulation is added to these data packets, a tunnel network is created. Then tunneling encapsulates the data packets from one protocol inside a different protocol, and then it transports the original data packets unchanged across the network. A lower layer or same layer protocol can be carried through this tunnel, which creates an overlay basically. Now, in SD access, this overlay is referred to as what we just saw, a fabric. Policy plane in SD access is Cisco TrustSec. So the goal of Cisco TrustSec technology is to assign an SGT, a security group tag value, to the packet at its ingress point into the network. An access policy elsewhere in the network is then enforced based on this tag information. And we'll see more on that in the upcoming slides. Thus, Cisco TrustSec replaces the access policy from VLAN and IP address based to identity-based grouping policy known as group-based access control, which is also called GBAC. Now let's quickly talk a little bit about the fabric devices, their roles and their responsibilities. So let's start from the fabric edge node. So fabric edge node is equivalent to an access layer switch in a traditional campus LAN design. Endpoints, IP phone access points are directly connected to edge nodes. The fabric control plane is a host tracking database which tracks all endpoints in a fabric site and associates the endpoints to fabric nodes. Fabric border node serves as the gateway between the SD access fabric sites and networks external to the fabric. So the networks that are outside of the fabric. The border node is the device which is physically connected to a transit or to a next hop device, which is connected to the outside world, which gives you connectivity to the unknown networks. Fabric wireless controller, it is a fabric device which connects fabric APs and wireless endpoints to the SD access fabric. And then at the top, we have two controllers, the Catalyst Center, which acts as a controller for SD access fabric, which provides simple GUI and APIs for the intent-based automation of wired and wireless fabric devices. It also provides visibility on the fabric by leveraging network data collectors to analyze and to monitor SD access fabric network. And then we have Cisco ICE, which acts as identity store and policy engine by leveraging NAC and ID services for dynamic endpoint to group mapping and policy definition. Now, fabric-enabled WLC connects and it registers wireless endpoints to the control plane. It creates a CapWeb tunnel will be used to manage the APs from the WLC, while data plane traffic traverses the fabric, which bypasses the need for endpoints to go through the WLCs. So I can post a link on the chat or in a few minutes, which goes on the details as to which are the devices that are like, what are the supported platforms for fabric-enabled wireless, if you want to learn more on that. Then SD access extended nodes. We also have extended nodes that provide the network connectivity and the ability to manage your IoT devices, which are in outdoor and non-carpeted environments, such as your distribution centers, your warehouses, or your campus parking lots. This feature extends consistent policy-based automation to Cisco Industrial Ethernet, Catalyst 3560CX Compact, and Digital Building Series switches. It also enables segmentation for user endpoints and IoT devices connected to these nodes. Using Catalyst Center automation, switches in the extended node role are onboarded to their connected edge node using an 802.1 trunk over an Ethernet with one or more multiple physical link members. So extended nodes are discovered using zero-touch provisioning or using plug and play. The The benefits of extending Fabric capabilities using extended nodes really provide the operational simplicity for IoT using Catalyst Center based automation. It also provides you the consistent policies across IT and your operational systems, and also greater network visibility of IoT devices. Again, for supported platforms, which devices are supported, which platforms are not supported, there is a compatibility matrix, and I'll post that link on the chat in a few minutes. Before I do that, I want to quickly go over the Fabric workflow. So in order to begin with the segmentation or with your Fabric creation using Catalyst Center, we need to make sure that these steps are done correctly. So I've listed out the few things that need to be done, like you need to first get started with creating your network hierarchy on Catalyst Center, defining your network settings, reserving the IP pools, and then identifying different devices and what their roles are going to be in the Fabric. Now let's talk about segmentation with Cisco SD Access, which is like an important, or you can say the meat of SD Access. So I want to spend a couple more minutes in this section. So let's quickly look at what are the challenges in the traditional networks, like what are the traditional way of doing things. What we used to do, or what we are used to doing, is that for every new identity in our network, we spun a new VLAN just to keep that segregated, just to have a separate entity in L2 that does not talk to each other, and it can just be reserved for its own role. If you want a new voice VLAN, you have to spin that. For IoT, for cameras, HVAC, you would, every time you do that, you would spin up a new VLAN. So these things will be or becomes really hard to manage. And also to when you are looking to extend those VLANs to multiple sites, that can cause layer 2 loops and broadcast and all those kind of things which are super hard to manage. And those IP ACLs are also, again, very super hard to manage. So we want to move away from that kind of segmentation, which has always been there in our thought process. And if you want to segment something, if you want, the solution should not be creating a VLAN. So if you want to segment something, create an L2 or L3 boundary. We want to move away from that kind of process or that we are used to of doing things. Then also don't forget the IoT devices that are coming on board in our network every day. So many people are using different devices, like phones, watches, laptops. It's becoming more and more difficult to manage the network infrastructure, but also different devices that are coming in. So manageability basically is becoming a big challenge in traditional network. And then lastly, the complexity behind troubleshooting is immense as well, because no two networks are same. So first you need to learn the network and then you can troubleshoot. So again, the issue resolution becomes really slow as well. So we want to move away from that, and let's see like how we can do that. So this is how we are used to doing the segmentation. We would manage the IP access list, hundreds of lines of IP ACLs, which most of us don't have an idea as to why they're configured. And that's usually the case in most of the companies. People come, people leave, new people come. Like if you look at it, they will have no idea why something was configured previously. And it becomes hard to manage and even modify or edit a single line, because it's not really easy to understand these complex ACLs, and almost impossible to verify after a few months or after a few years. This is one of the example, you can say, how we can solve this problem that we saw on the last slide. So if you pay close attention, there are no IPs or subnet information here. We are filtering, allowing, or denying based on a tag value, which is more easier to understand and more easier to define a business intent. For example, a group of users type employees cannot access development server. However, only user type developer can access development servers. And we can add more and more groups to this policies just by adding more entries. So this is how it looks using SD access segmentation. So to quickly summarize this with SD access, using SD access segmentation, we get greater operational efficiency. So there's no need to write those complex IP ACLs. We get consistent wired and wireless policy. So the process of assigning the policy in SGT is the same, irrespective of whether someone is connecting wired or someone is connecting wireless. There is no real dependency on IP anymore, and the use of security group tags makes it very easier to edit and redeploy the policy in no time. So how do we actually implement it? Again, Cisco ICE is highly recommended, and it plays a major role in automation and deployment of segmentation strategy. Cisco ICE here is the one which is going to identify who, when, what, how, and authorize the legitimate endpoints, no matter how they are onboarding into the network, whether wired, wireless, or they're the remote access clients. So we start the segmentation by integrating ICE with Catalyst Center. Once we integrate Catalyst Center with ICE, it establishes the trust relationship. Then all the policies and security group tags that you create on Catalyst Center will be pushed to ICE via APIs. And ICE, in turn, will push the policies to the network devices and will share the contextual information with Catalyst Center via the PX Grid connection. There are certain things that you need to consider for the integration, like the ports and protocols that you need to open, like the SSH port, so that Catalyst Center can SSH to ICE and exchange the certificate. Then you also need to allow Catalyst Center to communicate with ICE over external RESTful services or ERS APIs. So the ERS service must be enabled for reading as well as for writing. These APIs are all enabled in Catalyst Center. However, the ERS service on ICE is disabled by default. So we need to enable the ERS service for both reading and writing on ICE so that Catalyst Center can push instructions or it can push the policies into ICE. And then lastly, the PX Grid service needs to be enabled as well in order to share the contextual data, in order for ICE to share the contextual data back to Catalyst Center. Now, Catalyst Center basically supports two concepts of segmentation, macro and micro segmentation. Let's talk about macro segmentation first. Basically, macro segmentation in Catalyst Center refers to creating virtual networks, which is really what we refer to as VRFs in traditional networks. So it is really the separation of control plane, just like two different VRFs in traditional networks. By default, interfaces assigned in one VRF are not visible to the other VRF, and so no communication exists between them at all. In the same way, by default, there is no communication between two virtual networks as they are part of different routing domains. So for example, in your enterprise network, you would create a separate virtual network for different groups, like a separate VN for your building management and a separate VN for your corporate users, for your campus users. So for every VN that you create, Catalyst Center will automatically push the config of VRF on your edge and your border devices. And by default, there would not be any communication between them. However, there are ways to make them communicate if you want to. For that, you can do route leaking in your external router, and you can leak routes from your global routing table to your VRF routing table. So that's the concept of macro segmentation. The other concept of segmentation is that Catalyst Center supports is micro segmentation, which means creating security group tags, which works exactly like how your VLAN ACLs used to work. So it is to filter a traffic within a subnet or within a routing domain, but with no complexity, unlike the traditional networks. Here, filtering happens on the basis of security group tags and not on IP addressing, which makes it really easy to deploy policies. We can have many security group tags sharing the same subnet, or you can say the same VLAN, and we still can achieve another level of segmentation. And that is what we refer to as micro segmentation. These tags are used to filter the traffic within a big subnet or in a VLAN. So let's say you have a VLAN and there are hosts in the VLAN, you want to deny traffic between them. In traditional network, you would create a VLAN ACL and do filtering, which is based on MAC. But here you would create access rules based on tags or color coding, which is very simple to configure and very easy to maintain and very easy to edit as well. Now, once you have your virtual network and your security group tags defined, then you create SD access policies. These policies, these rules, the security group tags rules that are defined, we create these contracts. The contracts basically defines as to who gets to communicate with who on Catalyst Center itself. We define these contracts on the Catalyst Center UI. So we can have granular restriction as to what is permitted between source and destination groups. And if we want, we can do a complete permit. We can do a full deny between any two groups as well. So it's completely based on our intent. So the good thing, or you can say the simple thing, that this is defined from Catalyst Center UI itself. So you do not need to get into the SGACL syntax and need to decode what is it that is being pushed onto the devices eventually. It can all be done from Catalyst Center UI. Now, once you define the SGTs, once we define the policies, we get this kind of visual representation of the policy matrix on the Catalyst Center. So this is where we will have the information of the source SGTs, the destination SGTs, and what contracts, what is the communication that we want to have between a source and a destination group. So if you double click on any of the cell in that matrix in the Catalyst Center dashboard, it'll give you the information of like a customized contract that you've created. So you can see the details like, for example, in this screenshot, you can see that the Lightning has restricted communication with the Energy Control Department and vice versa. So this is the kind of representation that you will see once you have everything created on Catalyst Center. Now with that, it's time to see all of this in action. So it's time for a quick demo that Casey has created for us. So Casey, over to you.
All right, hello, thank you, Kavita, and hello, everybody. I'm going to go over the demo that over SDA access for Catalyst Center. You can see I'm running version 2.3.7.5 right now. However, if you are running 2.3.7, I'd recommend 2.3.7.6 or greater. Okay, so what I'm going to do, I'm going to go through, because this is a getting started with SDA. I'm going to go through a lot of the basics of what you're going to do, what Kavita just covered, things such as fabric device rules, segmentation, scalable group access tags, virtual networks. So I'm going to cover all of these, where to find them, and how those integrate with ICE to enforce macro and micro segmentation. Okay, so first, what I'm going to do is I'm going to go to Design, Network Settings. And we're going to cover from the very beginning. You have the first thing you want to do is build out your network hierarchy. This is where you're going to define your fabric, and the devices within that site can be defined to the fabric. The next thing you want to do is make sure that you have ICE integrated. So ICE should be integrated in system settings, and then you'll come here and then you'll select the integration. In this case, this is the IP of our primary administration node, and you can give the shared secrets here. And what this is going to do is it's going to let Catalyst Center know that this is the ICE node, and when Catalyst Center comes down and configures network devices, it's going to do two things. First thing it's going to do is it's going to configure radius, TACAX, AAA server on the network device. Other thing it's going to do is it's going to configure it along with the shared secret that was just configured on that device on ICE itself. And one thing to make note of, that if you already have devices in ICE, you got to watch out for this, because if they're clones, if they're duplicate devices, it can cause some issues. So be aware of that. Take backups in ICE before you do this. Okay. All right. The next thing is IP address pools. This is where you're going to define your local area networks and how everything's going to segment within each other for your local area networks. All right. So we have the IP overlay. You can see the subnet we're using, IP underlay. This is for the point-to-point links within the underlay, and then LAN automation. Okay, so there, and I'm going to show you what LAN automation is. There's two methods to getting your network fabric ready. And the one is LAN automation, and the other one is provisioning. I'm going to go into the differences between those in just a second. But the IP underlay, if you're doing, say, LAN automation, for instance, what's going to happen? LAN automation, which is used in greenfield deployments. So new deployments, that's when LAN automation will be used. For your IP underlay pools, what's going to happen is when LAN automation is ran, it's going to use the IP links, the point-to-point links for ISIS, and configure that. ISIS is the only protocol supported for LAN automation. And then from there, during the LAN automation process, there are options for you to go in and select like redistribution into BGP so that it can communicate between sites and stuff. Then we have our IP overlay, which is where the SDA comes in, and then we can do further segmentation from this. So we can see that I'm on global right now. I have the IP overlay of 10.100.0.0 with a subnet mask prefix of /16. If I go drill down into London, we can see from all of those subnets that I had in global, I'm further segmenting them out and organizing them based off of the devices that I want to prevent, so like access points, endpoints for wireless, guest wireless, layer 3 handoff, it's all there. And that way, when I go and build out my fabric and assign, what virtual networks apply to what IP pools, that's when I can go ahead and map it out. All right. The next thing is for provision. Here's how you do LAN automation. If you're curious, you go to provision LAN automation and you click start LAN automation. Let's do it. And you would select the site. And how it works is you would select the site where the device resides under, and you would select, the idea is that you already have a device that is provisioned, and typically it's going to be either a core or distribution device that is going to scale downward throughout your network. And what this is going to do, so in this case, I'm going to select border, I'm going to select downstream interface to all of my network devices. And what Catalyst Center is going to do is it's going to come down, configure the border with DHCP, and then all the other devices below it, based on the interface I select, it's going to onboard these devices, establish connectivity to them, and configure ISIS across the whole network. It's very easy to implement. It's a very clean implementation if you are doing greenfield for you to transition into SDA. All right, so I'm going to go to provision inventory and show you the other option for this. Let me exit out of here. Provision inventory. And this is basically the other method. You could either do PnP to provision your devices, which is beyond the scope of this. It's plug and play. It's for automating more brownfield related stuff where you can use templates. Or you can just discover pre-existing devices using the discovery tool, which is also beyond the scope of this, and then provision these devices, and then it'll go there. It'll show up here in the inventory. Once it shows up in the inventory, a big thing is you'll want to make sure that the device role is selected. So you'll want to make sure it's at core. Let me table columns. Let's see, device role. Yeah, device role. Okay. Inventory. I have to zoom out a little bit. For some reason, device role is not showing. I believe it might be under a different default. device role. Yeah, it's not showing. There we go. I don't know why that one's showing. Anyway, so we have core right here. So we can see our various device roles. You want to make sure these match, right? So like we have our border role, our access role. So these access points, they cannot be changed for their roles. There's shared services, border, router, they're specified, and this is good practice to go in and do this when you're before you start building out your fabric. So border router for here, and here you can see all the various roles you can put here. All right, and that gets us ready to where we can do the actual SDA provisioning. So I'm going to go to provision, fabric sites. So SDA access section, fabric sites. I'll start with fabric sites. There are two UIs you can use. This is the newer UI. It does default to this. You can take a tour, or you can click here and go to the legacy version, which is going to eventually be retired. But this is the legacy version. You do have the option to navigate by means of that. There are a lot of enhancements where you can audit and track a lot of get a lot of data, track a lot of stuff, and there's much more easier workflows to follow, such as create a fabric site, configure multicast. It'll guide you through it rather than the other option, which is a more manual approach. It does work. It's just this is the new and improved layout. Okay, so I'm going to click here and review our current fabric site. So we have London. I'm going to use London, for example. If you wanted to, you click create fabric site. And then what it's doing here is it's looking at my site hierarchy under London, and it recognizes all the devices within and how they're connected. And then what I can do is I can click a device. I can select various, that shared services device needs to be provisioned to the site before rules can be assigned. Shared services isn't part of a site hierarchy, so it's letting me know. It does know about it, but shared services is not part of the site, part of the site exactly, because what it's doing is we use that to connect Catalyst Center, ICE, all the other servers together so they can communicate. And so it's just warning me about that. However, if I click on border, what I can do is I can check edge, I can check control plane, I can select, do I want to do LISP, BGP, or LISP PUB-SUB. We're going to go more into in a more advanced webinar, but this LISP PUB-SUB. LISP PUB-SUB is the newer format. Control plane node is going to enable that. You'll notice if actually I'm going to go to border node and then enable layer 3 handoff. So this is border. So this is going to be the ideal role to put it as. And what it's wanting is a local autonomous system number. We have a Fusion router connected to this, and the AS number is going to be, it won't be the AS number of the Fusion router. It'll be the local autonomous system number configured here. However, when you configure a transit, that'll be the Fusion AS number. And then, all right, so edge node right here, it says device provision to a fabric zone cannot be added as pure edge on the fabric site. This is because right now I am within my site hierarchy. I'm in London right now. I'm not within the fabric zone. In order for me to, and you'll see that this border is not even in a fabric zone. We do have devices in a fabric zone, like edge 2. It is in a fabric zone. However, if I do that, it's meant to be an edge. I'm not in the fabric zone. What I need to do is I need to go over here, site 1, and then select the actual device. And now I can click add, and I'll go ahead and add it in. And then we have our layer 3 networks that we'll configure. Right now, we have Campus VN and Infra VN. We have our VN IDs. We can add more layer 3 networks. And again, as Kavito was mentioning, I mean, virtual networks are essentially, you can think of it like a very large routing table that does macro segmentation. So we have our layer 3 networks, and it is mapped to an IP pool that's created. So Campus VN mapped to an IP pool. It's also mapped to an Anycast gateway, because within that pool, it needs an upstream SVI to communicate with and route traffic for different clients over to. So these are what the Anycast gateways are meant for, and you can see that they're mapped to the layer 3 virtual networks. All right, so other than that, we have our authentication templates and our port assignments where you can get more granular within your configurations for these. All right, and then last thing I want to cover before we switch over to virtual networks, ICE, and scalable access control is the actual transits themselves. So for transits, we currently have a fusion. You can, to create a transit, you can select which one you're going to do. Do be aware of if you're going to be doing LISP PUB-SUB and LISP BGP or LISP BGP or IP base before you build out your fabric. And then you'll configure the transit here. And what the transit does is it's going to help with mapping between sites, right? So it's going to use things such as if you're using scalable group tags, right? Let's say those transit outside of the network, you would need, instead of SGTs, they're going to be converted to SXP protocol, which is going to be tagged, framed, and then it's going to be sent across the WAN, then converted back to SGTs in order for it to get enforced. Okay, so here's our current fusion setup. We just have IP transit type, and then we have our autonomous system number of our remote device, our fusion, IP based. Okay, the next thing is virtual networks. So this is back to the, actually, we just covered virtual networks, so this is the macro segmentation. The next thing that ties into this, because remember, Kabito is talking about macro and micro segmentation. So you can think of these VNs as think of it like a little bubble, big bubble that includes a lot of stuff. But within that, we need to further micro segment each of them. How we do that is we go to policy, group-based access control, policies, and we can see that we have a contract right here. Notice at the top, it says migration is complete. Catalyst Center will be the policy administration point and screens of security groups, access control. So basically, you have to, when you install Catalyst Center and you integrate ICE, there's going to be a message prompting you to perform the migration, which you don't really need to do much to do it. It just makes a change within Catalyst Center and ICE on what happens here. And essentially what that does is it means that, I'm going to show you ICE in just a second. It means that I can only configure these policies on Catalyst Center, and then it syncs over to ICE. Doing so will, it's going to prevent any overwrites, anything like that, any confusion with the policies. It'll configure that. But here you can see that we are, for like contractors to development, for instance, we're denying all IPs. And what this looks like is we have our security groups, the contractors right here, and then developer servers. These are all configured within Catalyst Center. And instead of defining, if you're familiar with access lists, like instead of defining access lists by IP address, we're now mapping users by username and assigning them to a security group. This makes access lists much more manageable, and it makes it a lot more dynamic, less static, which increases security. It helps because there's not as much of a burden on managing access lists. It makes it a lot easier to manage security that way and make sure it's tight and where it needs to be and adaptive at any point in time. All right, so now because these are defining it based off of user, now I can click access contracts and I can create various contracts here. I have deny IP, permit IP, allow web traffic, whatever. And then I can go to policies. And then let's say I wanted to configure another one. I could do developers to extranet, right? Change contract. And then I could select allow web, change. What that's going to do is it'll go ahead and allow that. Okay. All right. So the next thing is I'm going to go over to ICE, right? So this is ICE. It's integrated with Catalyst Center. And what I'm going to do is show you first off the deployment. So I'm going to go to administration deployment. And we can say I only have one ICE node. It's acting as all the nodes, but you can have multiple nodes going on. This is just for a single deployment. Big thing here is you want to make sure that PX Grid is toggled, it's enabled. So not only is it primary administration node, it's a PX Grid node as well, which is important for those SGT tags and everything to get communicated correctly. Okay, next I'm going to go to policy, and then I'm going to go to, not profiling. Policy elements, results. And I'm going to go into two things. First one is authorization profiles. Right here, make note of this. This is actually this one, infra. You'll see this authorization profile in our actual policies. So the policies are the ICE policies. What they're going to do is they're going to break it down by three things. It's going to check a condition. It's going to check, does this user exist? Does this user who's trying to sign in via 802.1x or MAB, does this user that's trying to sign in match any of these policies? And if he matches them, he's enabled access based off of what I've defined here. And the access that I've defined here is one, it's macro segmentation and is micro segmentation. And the authorization profile, this is what you had set here. You can set the AP virtual network right here. Is do a select item, and then you would run through. You could run through various names here. I could select. I could get even more granular, but this is what you do. You select the VLAN and then the ID name of that VLAN. And what that's going to do is this has to match what's in Catalyst Center, and that's going to map to the actual virtual network. Okay. Next, before we go to policies, I'm going to go over to the actual PX Grid or TrustNet. Let me see. PX Grid services. Actually, TrustSec policy. So what you'll do, you'll go to Work Center's TrustSec and then TrustSec policy, and it's going to bring you to Matrix. Give it a sec to load. There we go. Okay, you can see like it's synced up with ICE. We have our deny IP or deny IP that we saw earlier. So it's synced up with Catalyst Center. Catalyst Center is managing it, and it's syncing over here. And then we have our developer servers to internet permit IP, and that's enabling access in. Also, if I go to components, I can see that the SGT tags that I configured in Catalyst Center are already migrated over here as well. And so it's communicating with ICE here. Okay, so authorization profiles define virtual networks, and then SGT tags provide the micro segmentation for those virtual networks, which now leads us to policy sets. All right, this is the final bit. This is where it all comes together. So we have our default policy, which is going to check MAB or 802.1x. What method are they doing? And it is permitted. And then what are they authorized for based off of how they're authenticating? Okay, right here, we have our identity group. So any user who's under the employee identity group, if they are under that group, they're going to get assigned the infra authorization profile, which is going to put them in that virtual network, and then the security group of employees. And then contracts, everything is going to be applied based on that. And that is the biggest thing when it comes to segmentation with SDA. The other thing is LISP, which we're going to cover in a more advanced webinar coming up, actually next month. But this concludes the demo for kind of like a getting started overview of SDA, and I hope you learned a lot from it. I'm going to go ahead and hand this back over to Kavita. Kavita, over to you.
Thank you, Casey. So with that, it actually is time now to wrap our session with some key points to remember. Cisco SD Access basically, in Cisco SD Access, control plane manages the endpoints to device relationship. So that is something that we need to keep in mind. Other than that, segmentation provides the operational performance. It protects the vulnerable devices. It protects the data. And Cisco ICE is a key component of microsegmentation. So if you want to get the real benefit of SD Access Fabric, then it is essential to integrate ICE with Catalyst Center. And then virtual networks and SGTs, as Casey just showcased us in the demo, it provides us 2 levels of segmentation in Cisco SD Access Fabric. So with that, it's time for any Q&A. If there are any questions, then we can take those. And while we are pulling up the Q&A, I also want to quickly highlight the upcoming webinars. We have Catalyst Center SDA series is currently going on. Today we had the Getting Started. And part 2 is going to be covering the advanced features of SD Access, like LISP protocol, and I think Multicast would be covered as well, but it would be some advanced features. There'll be more information coming out on that soon. And another one is part 3, monitoring SDA. That would be in May. So stay tuned for those. And that's it. That brings us to the end of our session. Please don't forget to fill the survey. We would love to hear from you. We would love to get your feedback on what we have presented today and what more would you like us to present on SDA. So that's it. Thank you very much, everyone, for joining. And thank you, Casey. Thank you, Tanner. Thank you, team. Everyone have a great day. Yeah. And any questions? Yeah, sorry, before we wrap that up. Yeah.
All good. Thanks so much, Kavita and Casey. Thanks so much for the demo. Always love a good demo anytime we're able to put on these virtual events. We are at the Q&A portion of today's event. We are close to time here, but I do want to get in a few questions for our presenters here today. And Kavita or Casey, feel free to speak up on either of these questions, whoever would like to take them. Let's start with this first one. Is ISE the only supported AAA server?
So I can take that. ICE is highly, highly recommended, as I mentioned in my presentation as well. For SD Access, the meat of SD Access Fabric is in microsegmentation. So when you really create those SGTs, when you do the segmentation within the subnet is when you get the actual flavor of SDA. So that is something that can only be achieved when you have ICE integrated with Catalyst Center, because ICE gives you the SGT information, the TrustSec. The TrustSec needs to be configured for that as well. So if you are planning to do microsegmentation, create SGTs, then yes, you need to have ICE. But to create to get started with SDA or to create an SDA fabric or to create virtual networks, you don't really need an ICE, but it's highly, highly recommended again. Yeah.
Great. Thank you. Thank you. This next question, what versions of ICE and Catalyst Center are required for SD access?
I think, Casey, you're
Got you on mute, Casey.
Thank you. Sorry about that. All right. So yeah, it really depends on what version you're running. The best bet is for you to check out the compatibility matrix, and from there, it'll define the recommended version. Be it like if you're running Catalyst Center 2.3.7.6, it may recommend ICE version 3.1. And you can just check out the compatibility matrix. Search Catalyst Center compatibility matrix on Google, and it'll come up, and then you can compare and contrast between them.
Beautiful, beautiful. Let's get to this this last question here before we wrap up. Do I have to have a software-defined fabric in order to utilize SGT policies?
So in order to get started with creating an software-defined fabric, you do not need SGT policies or vice versa. But you do require, SGTs require you to have ICE integrated and TrustSec configured, as I mentioned earlier. So you can leverage the SGT policies without a fabric. But again, the real meat of SD access is in creating that segmentation within the fabric, creating the micro segmentation and eliminating that need to create the segmentation in a traditional way using the VLAN ACLs. So for that, we need ICE integrated. However, this will not include micro segmentation defined by the fabric due to virtual networks not being deployed.
Great. Thanks so much, Kavita. We are up against time here real quick, but I do want to kick it to Casey once more. Casey, is there anything else you'd like to touch on here before we wrap up?
All set here. Be sure to register for the upcoming webinars for SDA. Thank you all for joining. I hope you all learned a lot and have a great day.
Thanks, Casey. Kavita, is there anything else that you'd like to touch on?
That's all from my side. Thank you, everyone, for joining. Hope you liked the session. Looking forward to your feedback. Thank you, everyone. Have a good one.
Great. Thanks once again to Casey, Kavita, Julio, who helped us out on the Q&A side today on Slido, as well as our producer, Carlo Bobiles, and the whole team for bringing your knowledge to the Cisco community. If you do have an additional question for our presenters, we'll keep that Q&A panel open on Slido for a couple more minutes. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. You can also follow up with any further questions, view resources from today's session, as well as view its recording through our post-webinar discussion thread on the Cisco Learning Network. Come chat with us, come talk to us, ask any questions. We'll be happy to help out. As Kavita mentioned a moment ago, we also ask that you please take a moment in answering any questions through our post-event survey on Slido. That helps us prepare some future sessions, so your participation is greatly appreciated. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.